Hi, this is John Block of Mr. Block Tutors Math. Recently, I had a seventh grade student of mine ask if there was a formula or a method for finding a missing side of a triangle. Well, the answer to that, there's a lot of methods. There's the law of sines, we'd have to know some angles. There's the law of cosines, we'd have to know an angle, a couple sides. There's the trig functions, we'd again probably need to know an angle. But probably the one method that's used a lot that we're going to talk about today is the Pythagorean theorem. I'll spell that for you here. Pythagorean theorem. The Pythagorean theorem deals with right triangles. And basically, that's supposed to be a straight line. It says that the sides of a right triangle are related. If these sides A, B, and C, usually A and B, well, almost always, A and B are the legs of the triangle. The legs make up the right angle. And C is that special side across from the right angle that's called the hypotenuse. Kind of a cool name. And the Pythagorean theorem says this. It says that A squared plus B squared equals C squared. In other words, the sides of a right triangle are related in this way. Now, we can use that information to solve triangles. Solving triangles means finding an angle or a side. So suppose we have a right triangle, and we know that that side's 7, and maybe that side's 6, and we don't know this side, C. Well, there we go. There's A, there's B. So I have 7 squared plus 6 squared equals C squared. See, all I'm doing is just taking my example right here, A, B, C, plugging them in, A, B, C, plugging them into the formula. So 7 squared's 49, 6 squared's 36, C squared's still C squared, it's unsolved now already. And we end up with 70 plus 15, 85. Now I don't want to know what C squared is, I want to know what C is, so I have to take the square root of both sides, and that's going to take a calculator for me, because I don't have that one right off the top of my head. So 85, square root of 85, turns out to be 9.2195444572292, and so forth. But I don't really need all of these digits, so I'll just round it to 9.2 or maybe 9.22. Okay, I'll round it to that. So let's put it back up here. So 9.2. Now that was pretty basic idea. We just took the squares, added them up, took the square root of it. Here's another example. Suppose I had a triangle that looked like this. And I know this time. I know that, whoop, I just did something wrong. I don't want to do that. Let's erase it. And I know this is, say, 12. And I know this is, maybe 8. I don't know this, so I'll call that A. So now I have A squared plus 8 squared equals 12 squared. So A squared plus 64 equals 144. Now I want A squared, and then eventually I want A. Whoop, just plain old A. So I'm going to have to use my little bit of equation manipulation and subtract my 64, so I get, looks like I get 80 then. And so then when I take the square root of both sides, now I go back to my calculator for this one, and in just a minute we'll return to this and we'll get a slightly different answer. Back to my calculator and put that 80 in. square root 8.944. Okay, I'll just say 8.94 this time, or 8.9. .9. There we go. Now notice, this isn't exactly right. This is an approximate answer because I've had to round it. In fact, I can't ever really get an exact answer on the decimal because the decimal goes on forever and I can't write forever. So I have to round it somewhere. So it's always, the rounded answer is always going to be, or the decimal answer is always going to be an approximate answer. But I could simplify this somewhat. And how I do this is I take factors of 80 and square root them all until I find a perfect square. Well, for instance, if I took 4 times 20 square root, there's a perfect square, but there's another 4 in here. So it would be 4 times 5. Take the square root of that. Now that equals square root of 4 times square root of 4 times square root of 5, which would then be 2 times square root of 5, which would be 4 square root of 5. Now that is actually right there the simplified exact answer. You don't see that very often, I don't think. Maybe you do, but that's the approximate answer right there. So we've done 2 examples, one where we're finding C, and the other where we're finding either A or B. Now let's do an example completely different where it's kind of a made-up story problem. Let's make up a story problem. We'll get rid of all of this, and we'll draw ourselves a lake. And let's say the lake looks something like this. And go over here, and so forth around, and something like that. And we want to know this distance from here, that side, the right side, to the left side of the lake. Now there's a bunch of ways we could do it. For instance, we could kind of guess at where this is, get out here far enough that we don't have to walk in the water, and measure D. We could do that, couldn't we? That would work pretty well. We could take a boat and a very long waterproof tape measure, tie the tape measure to this side and row all the way across and see if we could, there's our little boat, and see if we could measure it. We could do that. Here's another way. This is a different way. We'll take and we'll go from here and we'll go out. And we'll go out till we're at a point where it seems like there's a right angle across the way. And then we'll go like that. That's about where it would be. And we'll make a right triangle in here so that the hypotenuse is in the water and the 2 legs are outside on dry land where we can walk. So we measure this and we say maybe this is 80 meters. And oh, this is quite a bit bigger. Maybe this is 120 meters. So then applying our a squared plus b squared equals c squared, we get 80 squared plus 120 squared. Whoops, I put a 0 there. Equals d squared. And we'll work that out. Now 80 squared, let's see. 8 times 8 is 64, so it'd have 2 extra zeros, so 6,400. And 12 times 12 is 144 with 2 extra zeros. D squared, put that together, 6400, we get 008, 20,800 D squared. Ah, Let's see if we get that right. Let's use our calculator and see if we got it right. So we go 80 squared, right there, plus 120 squared. There we go, and that equals 20,800. And then 20,800, take the square root of 20,800, and we get about 144. 144. 144 meters. There, we've effectively measured our meters. Without actually getting wet. Well, that's the story for today. We've looked at the Pythagorean theorem with two just regular old triangles, and then an application setting a triangle on top of the situation. And again, this is John Block of Mr. Block Tutors Math. If you need help with your homework or getting ready for a test or some skills that you've missed along the way, give me an email or a ring or schedule an appointment, and I will get back to you and talk to you. Schedule a free consultation if you'd like. That's the way to go. And I'll talk to you about it. We'll work some problems and kind of get an idea where I'm at. And you can see if you think I'd help you or not. Thank you. We'll see you.